In section 11.2, we're going to talk about arithmetic sequences and series. What is an arithmetic sequence? An arithmetic sequence is when the members of the sequence, each term have a difference that's the same between one to the next. And that's what's called a common difference. So what do we mean by that? It means if I look at any two terms, let's take 1 and 5 that are side by side, they will have the same difference. So the difference between 1 and to the next term 5 is that you're adding 4. The difference between the 5 and its next term 9 is also a 4. The difference between the 9 and its next term, 13, is 4. So what would be the next term? Well, we'd keep on going with the same pattern. We'd add another 4, which would be that I'd get the number 17. And you could keep on going over and over again. So when we think of an arithmetic sequence, it's that you're adding or subtracting just a common number over and over and over again to get the next term. And that number that you're adding or subtracting each time is called your common difference. So let's take a look at a couple examples of arithmetic sequences and see if we can figure out what our common difference is. So in this first sequence in A, we're looking at the sequence 4, 10, 16, 22. So the goal with the arithmetic sequence is to see what are you doing from one term to the next and what's the pattern. So from 4 to 10, how do you get from 4 to 10? You're going to add 6. How do you get from 10 to 16? You're going to add 6. How do you get from 16 to 22? You add 6. So what is 6? That's what our common difference is. Notice it's positive because we're adding 6 each time. So our common difference, D, is just a positive 6. Let's look at another example. Let's look at another arithmetic sequence in problem B. In problem B, we've got -8, -12, -16, -20. So again, let's start with the first term and ask how would we get to the second term? So to get from -8 to -12, we'd subtract 4. To get from -12 to -16, we're going to subtract 4. Let's see. To get from -16 to -20, we would subtract 4 again. So notice that each time to get from one term to the next, we're looking at subtracting or doing a -4 to get to the next number. So the next number, if we were to kind of continue, we'd subtract another 4 or do a -4, and that would give us -24. That's how we know what our common difference is. That's that D, which is -4. Each time to get the next term, we're adding another -4. Let's look at C. C is a little bit different because we have variables, but let's see what's going on from one term to the next. So notice our 1x turned into a 2x. So what did they do? To get from one to the next, they added an x. Well, to get from the 2x now to the 3x on the next term, what did they do? They again added another x. So that's going to be their pattern. So for the next one, if we were to keep on going, they would be adding another x, and that would be giving us a 4x for the next piece. Now let's see what's happening with the y's if we were to look at this pattern. Well, we started out with a 7y, and we went to having a 5y. So that means we actually added a -2y. Then we took the 5y and went down to a 3y. So again, we subtracted a 2y again. So continuing in this manner, if we subtract another 2y, we would get a positive y left over. And you could keep on going in this manner, but what this tells you is that your common difference, what you're doing is, well, each time you're adding an x, so you have a positive x, but you're also subtracting a 2y. This is important to split up between the x's and y's because when you're adding and subtracting, you can only combine like terms. So as a reminder, when you're adding or subtracting, you're only looking at combining like terms. And that's especially important when you're looking at arithmetic sequences, because that's what arithmetic sequences mean, is that you're adding or subtracting.